But isn't it the same for flows?
No.
Isn't it for the...
Well, flow is how quickly the gas is, right? So when you're working with volume control, you set a volume you want, and then the maximum flow. So your scalar and your volume and your flow should look identical in volume controlled ventilation. The only thing that changes is your pressure, right? And in volume control, your pressure is variable because it's going to be based on airway resistance compliance, right? And vice versa. In pressure control ventilation, your volumes and flows are variable because of airway resistance / compliance, okay? We're going to go over more of this on chapter 5 too. Okay, so now, looking at these scalars, okay, and you could have done it on the other one too, I'm going to go with this one right here, this breath. Can you determine airway resistance right now? What are your factors for airway resistance? Pip minus
the
plateau.
Do you have a plateau there?
No.
Okay. So on this image, I cannot. But what I'm going to do is I'm going to put a not a volume. Sorry, wrong one.
Oh, I already did it.
Okay. Let me put a.
Okay.
Okay.
Now you can.
So here's the plateau. Given these scalars, can you calculate out airway resistance?
Yes.
Yep. Right?
Yes.
So pip minus plateau divided by
Liters per second.
flow in liters per second. Okay. Okay. So
Because you have a tidal volume, right? No, that's sorry, not tidal volume.
what's my pip roughly?
40.
40.
Want to say 45?
Yeah.
Okay. And what is my plateau roughly?
38, 30.
35. Well, yeah. On a
Is it
diagram,
gonna
it'd
be
a little.
more on the test, like more?
Oh, it's computer
Okay.
generated. This is just
Okay.
my bad drawing.
Okay.
Okay.
No, I was just asking from like the practice problems.
No, I
too.
get yes. Okay, so now I need volume in liters per second. We're just going to say that this is 35. Okay. Here's my flow. I'm in 35. Flow is in liters per minute, right? Okay. So I have to convert 35. That's right. 60 seconds per. Okay. So when you do that, I know it's going to be a little closer to 0.5. Say it again.
I just studied them.
Can you do that on the board after so I know how to do that?
This?
Yes,
Yeah.
please.
Please.
Can we do that, Matt?
Yep.
This is
So-
where I'm getting.
Wait, this is so funny.
Same.
That all of us forget how to do
How did you do that?
That's what's tripping me up when it comes to
I
it.
just
Okay.
Me too. I can get myself to this point,
Too.
and then like.
And then I'm like, where's my calculator?
Yeah.
Okay. So I have 35 liters per minute, right?
Yeah.
Yeah.
Okay. But I need to convert it to seconds, right?
Yeah.
Okay, so there are 60 seconds in a minute, right? Okay, so when I do my division, minutes will cancel out, and what I will be left with is liters per second.
Oh, you didn't do the smaller ones, the bigger ones?
So I learned this was Did you learn differently?
No, I flipped the numbers.
Okay.
But it's.
Because I know, Joseph, you can show the other way, the division, because you do yours a little differently, right?
Oh, it's only the, you see,
No, I think
instead of
mine's
having the
the bottom.
35 below, I would have it
You're
on
on
top.
On top, right,
Yeah.
but I was gonna say, so if that's confusing people.
That's the only thing.
Okay,
Instead of the
alright.
35 going on the outside, it goes on the inside. That's what it is. That's why. Legit, like. I
Okay,
see what I'm doing
so
wrong.
therefore, 0.58 liters per second. That's how that's the conversion.
Totally didn't get that.
Hold on.
Wait,
So we got 5, 0.
Oh, yeah, 60.
well, there's an automatic decimal, we know there's a decimal known to be after the number 35.
Why?
Any whole number, if I put 7,
Add a 0.
there's automatically, we know the decimal point is after there, because that's a whole number.
Oh, okay. I was thinking something different. I don't know.
So just when you do your math, to carry where your decimal is supposed to be.
And you bring another
So,
0
okay.
down.
Bring another 0 down, right? Because that went in 0
60
times,
into
right?
500.
Okay. So 0.58 liters per second, okay? So I'm gonna slide this over here.
When do you stop adding the zeros? After just 2 for
It
you?
depends on what you're looking to do. If you were converting mils to liters, you wanna go 3 places over for mil, for liters,
Wait, can you say that again?
So at max 3.
max 3. But that's good enough, 0.58. Okay, so now this is gonna be 0.58, right? Okay, so from this scalar set, I was able to determine the pip, the plateau, and my liters per second. So you could definitely determine airway resistance from this information,
Yeah.
okay?
Okay, well.
So then it's 5 over 0.58.
So 10
10 over 0.58.
divided by
Now I know how to do that.
0.58.
Okay, now that's a decimal.
I don't know how to do that.
Huh?
How do you divide a decimal?
You can turn it into a whole
Okay, let
number.
me go back to this one so I don't mess.
The top goes on the inside.
Okay, so 10 divided by 0.58. We're gonna put
I think me too.
0.58 into 10. I want to move my decimal point over 2 places, which means I have to move that 2 places.
You missed the math.
58 goes into 100 once.
You sure you don't want to use a calculator?
No, because you can't use them on your boards.
I know.
Can you get us to the boards?
I'm trying. Desperately.
Is that 3 or 4 now?
Okay, so there's 1, and here's a 0 here, right? Okay, so 58 goes into 420. I'm just gonna,
I said 3 or 4.
We all failing in math class. We all failing. Okay.
I mean, you may just have to do it times 3 times 4 times 5
yeah.
to get there, but I'm just gonna,
Been doing
I'm gonna
it.
quicken the pace here. Okay.
There's nothing
Okay,
wrong
so
with
my
that. That's
airway
what I do.
resistance is 17 point something. Okay? I'm not gonna,
Yeah.
okay, so I was able to determine airway resistance. I'm afraid to ask if you can determine compliance from this.
Let me see. Let me see what you determine it.
Compliance is
Yes,
volume,
you can.
yeah, volume and pressure,
Yeah.
right?
Okay, what are you confused about? What can I help?
Well, it's one of these problems.
Okay, we'll come back.
I know,
Okay.
that's why.
You can determine.
Can we do compliance?
I would assume yes.
Okay, and I want to make sure everybody understands, because the question was brought up. We're only, when I'm asking you to calculate out compliance, it's always going to be static compliance. Okay? So therefore, the equation for static compliance is Okay, so what is your volume?
500. No.
400.
Okay, 400.
Okay, and our equation is plateau minus P.
There's no peak.
Okay, so plateau was 35.
Minus 0.
So there's no peak to 0. Okay.
Right.
Okay.
Okay, so you can figure out compliance, etc. Okay, and you can figure out your airway resistance because you've got every factor that you need in those equations.
I'm confused as to why the 58, the .58.
Because they had to convert to liters per minute. Are you, okay, I think I know where. So this one I'm gonna put in the parking lot. We'll come back to that, okay? So it's, I will come back to that. All right, so I'm in volume control because my volume and flow are constant. Okay, so what is my limit? What is really limiting the breath here? Is it the volume or the flow?
The volume.
The volume. When you're in volume control, volume is your limiting factor. Once it hits 400, you're done. Whoop, 400, no more.
We don't wait in the
No
pressure
more.
control, you said that the
Limit,
Was
pressure,
Oh.
and volume
Oh,
control.
the time limits the max.
Right.
Okay, that's what
Yeah.
I was thinking.
So with Denise, whatever control it is the same thing that limits it
For the most part, right now, yes,
for the test.
for the test.
Okay.
Chapter 5, we're gonna see it's a little different.
Whatever
But
controls
for the
it
test,
limited.
yes.
Okay, so now what's triggering?
Okay, so let's look at this
I
one.
don't
Very good. Okay, is there a patient effort here?
No.
So, who triggered it?
Machine.
Time! Because the ventilator gave it, right? Because no breath was attempted in a certain time frame, therefore, what was the trigger? It was time. It's a little too, let me do that.
Patient trigger.
Okay,
If there's a dip.
there is a dip.
That's a patient
That is
trigger.
a patient trigger. Okay, where is my
She's
trigger?
excited.
On the pressure form or the flow form?
Pressure.
Pressure.
So therefore, what was the trigger on this one?
Pressure trigger.
This was a pressure trigger. So it's patient triggered, but remember we have a choice between usually flow or pressure.
So wherever the dip is on which waveform, that's the trigger?
Right.
Oh, okay, I was just gonna ask that question. How do you do
That's what I was thinking. Okay, if it had been down here,
Flow trigger.
okay, it would have been flow trigger. Okay, so I can determine the trigger.
So I have one
Yes.
question. So we just said that first one was time triggered, but then that third one was pressure
Yes.
triggered.
Yes. Well, no. There's a difference between a machine, so here's where you have to discern machine trigger
Okay.
or patient.
And if it's
Trigger-
below,
The trigger for the machine to give a breath, the vent to give a breath is time. The trigger for the patient is either flow or pressure.
So, say we had that waveform and
Yeah.
that one was deflected.
Yes?
So, patient trigger. I mean,
So this-
pressure
So
trigger.
let's say I had them numbered.
Okay, then that makes sense now.
Okay, which breath on here
Okay.
is a patient triggered breath? Perfect.
That's all I was trying to get at.
Yeah.
Okay. Because
But they may ask you, and we haven't got there yet, but I could also look at this and determine what mode of ventilation, but we haven't got there yet.
Okay.
Okay? So, right now, we should be able to discern,
look at
was
my
it a
notes.
ventilator, timed breath, because I have a certain respiratory rate, patient did not, initiated breath in that time frame, the ventilator gave the breath. Or did the patient trigger the breath? So these are triggers, right? To start inspiration.
Take a picture of your notes, they're so neat. I'll show everybody.